Hello. So today we are going to be talking about a paired T. So a paired T is different than an independent T because your participants are paired or matched and are used for both conditions. Paired T also uses interval data and tests the hypothesis of difference. You will see that a paired T has two levels of one independent variable. Here are all of the different formulas that you are going to use to solve a paired T. So go ahead and pause the video and get those written down on a separate sheet of paper or wherever you want to put those. Okay, let's get started. A researcher wishes to discover whether the intake of orange juice affects potassium levels in the bloodstream. A group of 12 elderly patients is selected from a nursing home where previous diet has been controlled for. Potassium blood levels are measured for each subject. Then each subject is given a pint of orange juice and 2 hours later potassium levels are again measured. So how do we know that this is a paired T? Well, judging from the data that we have right here is in interval form. Also, potassium levels are checked in numerical form, so we have interval data. We are testing the hypothesis of difference because we're looking at the difference between the before and the after orange juice. And we are also dealing with a paired group because each participant is used for each experiment. So each participant is going to be used before the orange juice, and the same participants are going to be used for after the orange juice as well. Okay, so we already have our data here. So we are going to go ahead and start by making a table. So what I've done is I've taken the information from our previous table and I've put it into a new table just to kind of keep the information a little bit more organized, and it'll be a little bit easier to find the information that we're looking for if we create a table like this. So I went ahead and I assigned the before the orange juice as variable X and then after orange juice as variable Y. And this symbol over here is a new symbol that we haven't seen before. So this is XY. So all that you're going to do to obtain this is you're going to multiply this X value by this Y value and then fill that over here. And then for these columns, you're going to do exactly what it says right here. So X squared. So we're just going to take this and we're going to square it and put that over here. So I'm going to go ahead and get this table filled out. Okay, so I have gone ahead and filled out the table and all of the information for that. So like I previously stated, to get the XY value, you multiply this X value by the Y value to get this. And then for the X squared, you just squared this value to get this. And then the same for the Y value here. So you square this Y value to get the squared Y over here. And I have gone ahead and gone through the formulas and written down everything that we are going to need to solve the paired T. So we are going to need a mean for group 1 and 2. So I have assigned group 1 as the X variable and then group 2 as the Y variable. And so we're going to need a mean for both groups. We are going to need the sum of the raw scores for X and for Y. And then we're going to need the standard deviation for both, and then the standard error of the mean for group 1, standard error of the mean for group 2. We're also going to need an N value, degrees of freedom, the sum of X, Y, and an R value and a T value. So let's go ahead and see what we can decipher from the information that we have here at hand. So we can go ahead and get our N value. We have 6 participants in our study, so the N value is 6. Degrees of freedom for paired T is N minus 1. So if we take 6 and subtract 1 from that, that is going to give us 5. Okay, so what we can do from here is, why don't we go ahead and add all of these up here. So when we add the X squared, that is going to give us this value here. So we're just going to add all of these up just like we've done in all of our other statistical tests, and that's going to give us the sum of the raw scores squared for the X variable. So when we add all of those up, that is going to give us a total of 3,376. Okay, so let's go ahead and do the same for the Y variable. So we're going to do the exact same thing. We're just going to add all of these together, and that is going to give us this value here. So the sum of the y variable squared. So when we add all of those together, that's going to give us a total of 3,968. Okay, and let's go ahead and do that for the xy as well. So just add all of these variables up, and those are going to, that's going to give you this value here. So when we add all of these up, that is going to give us a value of 3,654. From this table, we can go ahead and get our mean values for our x variable and our y variable. So to get the mean, we are just going to add these up here and divide by how many we have. So for the x variable, when we add all of these up, that is going to give us a value of 142. We're going to divide that by 6, and then that is going to give us a mean of 23.67. Okay, so that is for our x variable, so 23.67. And then for the y variable here, we're going to add all these values up. That will give us 154. We're going to divide that by 6, and then that is going to give us a mean of 25.67. So go ahead and put that here, 25.67. Now that we have our mean and our sum of the raw scores for the x and y variable, we can go ahead and start working on our standard deviation. So we're going to have to do 2 standard deviations because we have 2 different groups here. So let's go ahead and get started on group number 1. So we're going to plug this value in, the sum of the raw scores squared, so that's this value here. So it's going to be 3376 divided by our n value of 6. And we're going to subtract our mean here of 23.67. That is going to be squared. And then square root everything. So when we divide this out, that is going to give us 562.67. And then 2367 squared is going to give us 560.27. Okay, and then when we subtract those, that will give us 2.4, and then square root that out, and the final answer for that will be 1.55. So our standard deviation for group 1 is 1.55. Okay, so let's go ahead and do for group 2. So we're going to do the exact same thing with just different numbers. So start with this value here. We've got 3968 divided by our n value of 6. Subtract the mean over here of 25.67. That is squared. And square root all of that. Okay, so divide this out here, and that is going to give you 661.33. And then we're going to subtract this squared value here of 658.95. Subtract those two, and that is going to give you 2.38. And then when you square root that out, you are going to be left with 1.54. So our standard deviation for group 2 is 1.54. And don't forget to round at every step of the calculation. Next, let's go ahead and start on our standard error of the mean. So now that we have our standard deviations, we can go ahead and plug that in. And once again, we're going to be doing it twice because we have 2 different groups. So let's go ahead and start for group 1. So the standard error of the mean for group 1, we're going to start with our standard deviation for x, which is 1.55. And then we are going to put that over our n value of 6 minus 1, and then that will be square rooted. So that's going to give us 1.55 over a square root of 5. And then when you square root 5 out, we'll be left with 1.55 over 2.24. Okay, so just divide that out, and that's going to give you 0.69. Okay, so our standard error of the mean for group 1, or the x variable, is 0.69. Okay, so let's go ahead and do the same for the second group. So we're going to start with our standard deviation over here of 1.54. And then since we already did these calculations here, we can go ahead and just put that over 2.24. So when we divide 1.54 by 2.24, then that is going to give us 0.69. Okay, so our standard error of the mean for group 2 is 0.69. Now let's go ahead and find our R value. And we only need to do one of these because we've got the mean for group 1 and group 2 and the standard deviation for group 1 and group 2 in the R value. So let's go ahead and plug those numbers in. So our sum of x, y is 3654 over our n value of 6 minus our mean for group 1, which was 23.67. And then we're going to multiply that by the mean for group 2, which is 25.67. And then we're going to put all of that over the standard deviation for x, which is 1.55. And then the standard deviation for y, which is 1.54. Okay, so when we divide this out, that is going to give us a value of 609. Okay, and then we're going to multiply these two values here. That is going to give us a value of 607.61. And then we're going to multiply these two values, and that will give us 2.39. Okay, so subtract those two, and you'll be left with 1.39 over 2.39, and then we divide that out, and that will give us 0.58. Okay, so our R value is 0.58.